Welcome to Oklahoma Gardening. This week we're going to learn about organic vegetable production at the West Watkins Research Center in Lane, so stay tuned.
Oklahoma Gardening is a production of OSU Extension as part of the Division of Agricultural Sciences and Natural Resources at Oklahoma State University. Underwriting assistance is provided by TLC, Oklahoma's leading garden center, and the Oklahoma Department of Agriculture, Food, and Forestry, helping to keep Oklahoma green and growing.
We're at Lane Agricultural Center where we're going to take a look at organic vegetable production. And joining me now is Associate Horticulture Professor Warren Roberts. Warren, thanks for having us out here today.
I'm glad to be here, Kim.
Well, there are so many different ideas of what it means to grow organically. Can you help demystify this a little bit?
Well, Kim, the organic concept is pretty related. It's complicated. There's a lot of different facets of it. It involves production at all levels. It involves soil management. It involves environmental quality. It involves healthy foods. It involves nutritious foods. There's a lot of different aspects they're really all related, and it's hard to take out one part of it and separate it from the other because in this interrelated system, everything works together in food production. It can include plants, it can include animals, it certainly includes soils and soil management and environmental concerns as well.
And also there's going to be the ways we manage insects and other pests and weeds in the landscape.
Yeah, that's one thing that we've seen a lot here at our research center. We have seen that things that we might use as a cover crop or things that we might use as fertilizers can definitely have an impact on diseases and insects in the vegetable crops that we're going to be planting. So it's definitely all related.
Now, one of the things you mentioned is building the soil, and the soil is really the foundation of our vegetable production. How can we go about building a healthier soil?
There's a lot of different ways. I like to think of it in at least a couple of ways. I like to think of the nutrient content, nitrogen, phosphorus, potassium, calcium, etc. And plants do need all those nutrients. There's a certain number they have to have. They can come from various sources, but you have to have that nutrient base in there. Organic matter is also a very important part of really any soil system, but particularly of an agricultural system that's based on organic agriculture. That organic matter does so many, what I call really wonderful things. It can help water retention. At the same time, it can help with drainage if you might be having a drainage problem. It can help hold nutrients. It can help with oxygen exchange. It can help the roots to grow through the soil, basically a better tilth in the soil. So I think that organic matter is really one of the main foundations in the soil that we need to really work with, try to build that base up.
What are some of the sources that we can use to build organic matter?
You know, it really depends on where a person is located. I recommend locally available materials so that we can reduce transportation expenses. In this particular area, we rely a lot on poultry litter. It's a material that perhaps could be misused, but if used correctly, it's a good source of nutrients and a very good source of organic matter. In other areas where you may not have poultry houses close to your farm, you could look for any kind of animal manures, dairy cattle, beef cattle, little horse manure, anything like that. Now, I would caution you though, there is a possibility that there can be materials in the manures that are not accepted by the organic standards. So it's up to the grower. If you're going to find manures of some kind, you need to check it out and make sure that there are no prohibited materials in it. Other than animal manures, any kind of plant materials, it could be leaves that you collected from the trees in your backyard, grass clippings, basically any kind of an organic source like that. Sawdust is a good example. hay, straw mulch, papers. It really depends on where you are and what materials you have
What's
in your area.
available. And some of those items that we use for mulch, we can work into the soil later when we're finished.
Exactly. That's the good thing about a mulch. You can use it on the surface to protect from, to protect from high temperatures, to protect from moisture loss, to protect from weed growth, and then it will move into the soil as well. Cover crops is another material that's an excellent way to add organic matter. We have really worked hard trying to develop a system for cover crops that will have every winter on the field, and then with our vegetable crops going in the following spring and summer.
What are some of the cover crops that are most successful?
We've used a lot of different things. Crimson clover is one of my favorites because the crimson clover, it grows well in this area in Oklahoma, and at the same time it will add a good source of nitrogen to the soil. It's not uncommon to get maybe 100 pounds of nitrogen per acre per year. And so it's an excellent source of nitrogen in addition to being a good source of organic matter.
Okay, well let's look at some of the crops that you have growing out here as well.
Okay.
Warren, can you tell me why you became involved with organic research here at Lane?
Kim, it's one of the fastest growing segments in all of agriculture. In fact, a lot of figures show that it's growing by somewhere around 20% per year, which is really a phenomenal growth rate. We found there are a lot of consumers that are interested in, number one, growing their own organic crops. Or if they can't do that, they're interested in buying organic crops. And there, in a lot of areas, there is a shortage of organic produce. And yet at the same time, we found that there's a lot of questions. We really don't have a real good research base on which to make recommendations about how to grow crops organically. So that's really what we're doing here. We're trying to figure out what the problems would be if a farmer wanted to grow organically. And then we're trying to figure out the next step is not just what the problems are, but what are the solutions. So that's what we're trying to do, is figure out answers, figure out problems and figure out answers to those problems, and then make that information available to the growers.
Okay, so what do we have going on here around us with the tomatoes?
This particular part of the study, we're working with grafted tomatoes. The idea being there is that some tomato rootstocks may have more disease resistance than do other rootstocks. And in this particular part of the study here, we've got 4 different heirloom tomatoes. And we've grafted those. Part of the study is grafted onto a variety called Buford tomatoes, which has some reports that it has disease resistance. We've also grafted some of it onto eggplant. And in it, as a control, we have tomatoes that are just not grafted at all. So basically, we're trying to see, can we graft an heirloom, I'll call it the top of the plant, onto another, I'll just call the root of the plant, and can we grow a better tomato that way? Can we have one that's resistant to perhaps fusarium wilt or perhaps early blight? So that's what we're looking at here in this study, just seeing if grafting has any beneficial effect on it.
Excellent. Now I also noted your staking method, and we're always looking for a new method to stake tomatoes. Can you tell us about how those are tied up?
We have a couple of different systems in here. We have some determinate tomatoes, which are only going to grow 3 feet or so high. We have some indeterminates, and an indeterminate tomato will grow until something kills it, until frost or disease or whatever. So technically an indeterminate could grow forever, which means they could easily get 5 feet, 6 feet, 7 feet, 8 feet tall. So with those, we're using a different system. We've got a horizontal wire out the top of the row, and then we're using a string that's wrapped around each plant that goes up to the wire. And this way, these plants can go all the way to the top of the wire, and then they can go over the top and come back down if frost has not killed them at that time.
And I see you've just tied the string right onto the plant. Does that cause any problem?
It's just tied around the plant. Now, one problem that can happen, and you may see if you like that in here, the plant can be restricted by the string, so it's important that you leave enough room at the when the string is tied there that it doesn't constrict the plant. That can be a problem with that system.
Okay. Well, I see you have another interesting project over here. Let's go take a look.
Okay.
Warren, what are you looking at over in this area?
Kim, this is one of our attempts to lessen the impact of foliar diseases on tomatoes. In the organic tomato production system, we really don't have a lot of fungicides that are labeled to be used organically. And we have a lot of problems with foliar diseases, primarily early blight.
Okay.
So what we're trying to do is not necessarily kill the pathogen itself, but set up an environment in which it doesn't live and multiply very well. Most foliar pathogens need moisture on the leaf in order for the pathogen itself to grow. So what we're trying to do here is, to some extent, keep the foliage dry.
Okay.
And we've worked on this a couple of years, just looking at different systems that will perhaps keep the rain off the plants and perhaps keep the dew off. And dew can be as much of a problem as the rain. In fact, a lot of times it's more of a problem because dew can occur every night in a humid condition. So we're just looking at a system that hopefully will keep the foliage dry. It's not wide enough that it will keep the moisture from getting to the roots.
Okay.
But the idea is that the foliage itself will stay dry, and if it's staying dry, then even if the spores of a particular fungus happen to land on the leaf, hopefully they are not going to grow and multiply and cause a problem.
And this is clear, so we're getting plenty of light penetration.
That's what we're hoping. We worked last year with a metal top on it, but we didn't get any light penetration through it. So we've gone with a plastic system this year with the idea that we will get some light through it. Yeah.
Okay, and there's always going to be a little experimentation till you find the right material.
Yeah, right now, in theory, or maybe in philosophy, we're pretty certain that the system is going to work in theory.
Okay.
Maybe our engineering is going to take some work. As you can tell, we can have a lot of wind here, as you can anywhere in Oklahoma. And the plastic can get brittle and can break down. This that we've got this year is just common hardware plastic, nothing special about it. And the ultraviolet rays have made it kind of brittle.
Okay.
And the wind has really broken it down and started to rip it apart. There are materials that are designed for greenhouse covers that would hold up longer than this. Probably going to be a little bit more expensive, but we may go to that in next year.
Okay. Well, there's one more thing with the tomatoes, looking at pruning. I wanted to show everyone. Let's go take a look at that.
Okay.
So Warren, in this study, you're looking at different pruning methods and how it affects yields?
That's right, Kim. We've got some of the tomatoes in here are pruned and some of them are not. We've got determinate and indeterminate tomatoes in here, and the indeterminates will basically grow until something kills them, frost or disease or insects or something like that. And normally a typical method of growing an indeterminate would be to trellis it to just one central leader.
And that's what we have here.
That's what we have there. It's just basically a central leader from the ground to the top.
Okay.
And with this kind of a system, we'd have the string holding the tomato plant up to the horizontal wire there, about 5 feet tall. That plant will continue to grow. If nothing kills it, it'll be here in November when the freeze hits. But what we've found is that we don't seem to get as much yield out of some of our indeterminates as we thought we might. So our idea is that maybe we're pruning a little bit too much, because you have to have a certain amount of surface area. The leaf basically is where most of the photosynthesis is going to occur. And if we prune it too much, what we're afraid of is that we may be reducing the amount of photosynthesis that can go on in the plant, so we have less sugars and starches and so on for the fruit. So that's what we're trying to look at, and we're trying to say, okay, should we prune it the conventional method, or maybe we should not prune it quite as aggressively.
And so here you have a different method that you've been using with similar indeterminate type.
These again are indeterminates, but they have not been pruned at all. And you can see there are a lot of branches, a lot of side shoots that are coming up off the plant. Instead of having that one central leader, we've got, I don't know, 20 branches maybe or so per plant.
So time will tell how the yields compare.
That's right. We're collecting data off of it now, and at the end of the season, we'll be able to add up the numbers and see what they say.
I noticed there's several different varieties growing out here as well.
I think we've got probably about 10 varieties in the field here now. In the last couple of years, we had, I think, 86 varieties. All of these are what I like to call bite-sized tomatoes. Sometimes called cherry tomatoes, plum tomatoes, pear tomatoes, grape tomatoes, but they're all small ones. We're working with the Farm to School program where a farmer could sell their product, tomatoes or whatever else it might be, directly to a school. And the thing that we liked about these small tomatoes, you don't have to cut them, slice them, peel them, pare them, chop them. You take it off the vine, and essentially it's in a bite-sized portion as it is. So for a couple of years, we had about 86 varieties. We've thinned those down, picked some of the ones that do the best for Oklahoma, and now we're taking those best ones, a few determinants and a few indeterminants, and we're working with them now to try to help growth and help the yield. That's what the pruning is about, to try to take the best varieties and then figure out how to do the best cultural system for production with those.
Excellent. So a real integrated study you have here.
Yeah, I think you could say that. You know, one thing leads to another. When we figure out one part of the system, then it always brings up more questions. And then if you answer maybe one of those, it leads to something else. So it's all tied together. Yeah.
We have another integrated study here with the sweet corn.
That's right. We've got sweet corn and we've got pole beans in here, growing two crops at the same time in it. And to integrate it a little bit more, we've got two different planting dates in here. And then really our real treatments in here are observations that we're making with organic fertilizers. We've got, I think, 10 different materials, 10 different organic treatments, including poultry litter, rock phosphate, bone meal, alfalfa meal, corn gluten, things of that sort that can all be used organically. And we've got them in different combinations so that we can balance the nutrients as far as nitrogen, phosphorus, and potassium, but still do it from a lot of different organic sources. So I guess we've really got three treatments overlaid. We've got the organic fertilizers, and we've got the multiple crops and the multiple planting dates that are put together here.
So the purpose with looking at different fertilizer sources is sometimes if we keep using the same thing, we're not perhaps offering all of the variety of nutrients that are needed.
That's right. You know, every material that you get, whether it happened to be rock phosphate or alfalfa meal or green sand, you know, some of them may be pretty high concentrations of phosphorus, maybe some potassium, maybe some nitrogen. So depending on your soil needs, depending on the crop needs, you can mix and blend and come up with pretty much with a combination that you'll need for any situation, any soil or any crop. Yeah.
Well, thanks for sharing your research with us here today at Lane. I appreciate it, Warren.
Well, I'm glad to have you here, Kim.